Good morning, everyone. Welcome to the lecture today on midpoint theorem and converse midpoint theorem. We're going to define what a midpoint theorem is, and also we're going to prove that both midpoint theorem and converse midpoint theorem. All right. In the picture, you can see that there is a triangle ABC, and as per midpoint theorem, if you look at the statement, if D is midpoint of side AB and E is midpoint of side BC, if you draw a line actually connecting both D and E, midpoint theorem says that D will be parallel to BC and D is equal to half BC. So we're going to prove this like using the parallelogram properties and triangle congruence. How are we going to do that? Let me explain you. Let me select a different color here so that it's very clear to you. We're going to extend DE probably to infinite or like some kind of a distance there, right? And we're also going to extend what you call, we're going to draw a line C, a line passing through C, which is parallel to AB. So we call this intersection point as F. So what we're going to do is like we're going to draw a line CF which is parallel to AB, right? So because like I think let's call this triangle as one, like I think ADE, and let's call the other triangle as 2. So our objective is to prove that DE line is parallel to BC and DE is half of BC. Now, what is given? What is given is AD is same as DB, and they also gave that AE is E is the midpoint of AC. So AE is equal to this one. We also know that E, there is a vertically opposite angle that is created here, right? So what we are going to use is we're going to use our previous session's knowledge because CF is a line that is drawn parallel to AB. The line DF actually becomes the transversal. Based on the transversal properties, the alternate interior angles, angle ADE will be same as CF. Let's mark it differently with two lines here. Angle ADE will be same as CFE, right? So we also have like bunch of things like which actually say that because this line is parallel, like I think parallel to CF, this angle is same as this angle because it's an alternate angle. So we also know that E is a midpoint of it. So this particular line, AE in a triangle is same as this one, right? So we have two angles which are same and we have one side is same, but as per ASA, like I think what you call the side has to be included side. But we know that the sum of three angles in a triangle is 180 degrees. So if two angles are same, the third angle also has to be the same because of what will be the third angle? Let's say this is X and this is Y. This will always become 180 minus X minus 4, X plus 1. Right. So the same thing here. If this angle is equal to this angle, if what you call because of transversal, angle AD is equal to same, then at this angle also, angle A should also be same as angle C. So DAE should be same as ECF. So by definition of congruence of triangle, which is ASA triangle, so we can say that both triangles are congruent. Because both triangles are congruent and CF is parallel to BD. So we're going to exploit the parallelogram properties. What is a parallelogram? A parallelogram is a quadrilateral in which opposite sides are parallel and equal. And it's also important to know that in a parallelogram, it is enough for us to actually prove that two sides are parallel and equal. If they're equal, then it's a parallelogram because by triangle properties, if you put a diagonal, the other two sides also will become parallel and equal. So we're going to look at that more detail in parallelogram section. But for now, you see that how can I prove that something is a parallelogram? I can prove that like if two sides are parallel and equal, like that is always a parallelogram. So now going by the congruence of triangles between 1 and 2, we can always say that CF is equal to CF is equal to AD. So AD is here and CF is here. But what is AD? AD is nothing but dB. So we can say CF is equal to dB. So CF is equal to dB. Initially, we draw a line like I think AB is parallel to CF. So we can say that this is entirely parallelogram. What are the properties of parallelogram? Opposite sides are equal and parallel. So if you actually see that like BC, it becomes one side and DF becomes one side. So because BCFD is a parallelogram, FD is a parallelogram. So we can say BD is equal to CF. We can say BC is equal to DF. Right. How can you prove that like DF is like DE is half of it because these two triangles are congruent. The length of DE is same as length of DF. Right. So we can also say that DF is equal to BC. DF is nothing but 2 times DE is equal to BC. DE is equal to half BC. And this is precisely how you are going to say that both D is parallel to BC, and also we are going to say D is half the time of BC. And hence we proved the midpoint theorem. What is midpoint theorem? To summarize, the midpoint theorem says that if there are two midpoints, like I think around D and DE of sides of a triangle, then we can always draw a line connecting D and E, and that line would be parallel to side BC, the other side BC, and also it will be half of it, and hence we proved the midpoint theorem. Now let's look at converse midpoint theorem. Converse midpoint theorem is also useful for solving some of the problems. At times, I think converse midpoint theorem is more useful to solve the problem than midpoint theorem. So if you look at triangle ABC, what converse midpoint theorem says, they give one midpoint D and they don't give the other midpoint D, but they say that, hey, if I take one midpoint and I draw a line which is parallel to, so let's say I draw a line DF, which is parallel to BC, then what happens is E has to be midpoint. So observe the subtle difference here. So here they're not saying that E is midpoint. So they're saying that what you call, you take one midpoint and draw a line which is parallel to the base. Then if you draw a line which is parallel to the base, right, it intersects the other side AC at a point E, and point E becomes the midpoint. How does point E become midpoint is something that we have to prove, and we will tell, we don't know that this is the midpoint, but we'll have to prove in the similar lines. We'll have to draw another parallelogram, like I think in the similar way here. Let's see, the angle at E is always like I think equal because it's alternate angle. It doesn't have to do anything. They said that this particular thing, these two lines are parallel. Can we exploit some of the parallel line properties to prove that the triangle is exactly what you call congruent? So what properties we can actually use? They already gave that this particular thing is same as this, right? They also said that two lines are parallel. So what we can do is like BD, all right, BD must be same as EF. So we have to prove that these two triangles are congruent. So how can we prove that like these two triangles are congruent? One angle anyway they have given. So we have drawn again a parallel line like CF, which is parallel to AB. So the second, what you call, like I think the second angle is also same. As I said, if what you call two angles are like same, the third angle also has to be similar because this becomes, let's say this angle is X, this angle is Y, this angle becomes 180 minus X plus Y. So I think in the same way, like because it's a parallelogram, right? So you can always say that BD is same as what you call CF. Because BD is same as CF, this particular side is same as this angle is same, and the included angle, these two angles are same. So we can say triangle 1 is congruent to triangle 2. Because triangle is congruent, right? It has to follow that like this particular side has to be same as the other side. AE has to be same as EC. So the converse midpoint theorem is also not like something complicated. It is exactly similar. The steps are also something similar. What they give right now is they give what you call one midpoint is given, the other midpoint, I think we'll have to prove that like these two sides are same. So you can also like actually try to simulate that and figure out like I think how this is same. But ultimately, I think we're going to use two properties. One is parallelogram properties and the other one is the properties of congruence of triangles. Both we have covered like long back. The converse midpoint theorem, it's important to know, like let me reiterate. If a line is drawn which is parallel to base BC for triangle, which passes through the midpoint of one side, it has to go through the midpoint of the other side. And that is what converse midpoint theorem says. And converse midpoint theorem is super useful in solving some of the problems related to triangles. I think we can see like in one of the sessions, like I think how we are going to solve some of the problems here on converse midpoint theorem. Thanks for watching, and in case if you really like my videos, please do subscribe.